Good evening, everyone. First of all, thanks for the invitation. I'm very happy to share some cool stuff with you all. So let's get acquainted. My name is Mikhail and I love F#. That's basically everything you need to know about me. Maybe it's also that I'm a .NET developer for, I don't know, more than 10 years. Let's talk about you. Who here is familiar with F#? Okay, just a few people. That's cool. Okay, so let me try to show you what F# is and what we can do with it. So first of all, that's a functional language. It's one of the languages in .NET platform, no matter if you take full .NET framework or .NET Core. So as in probably any functional language, it has immutability by default. So you cannot mutate a variable. There is no such thing as variable at all. It has pattern matching with static typing and algebraic data types. I will show you what that means a bit later. But these are the key benefits of functional language such as F#. It's the best suitable language from my point of view for domain-driven design, for domain-driven development. Thanks to algebraic data types, which you will see in a couple of moments. There is a book written by Scott Vloschen about the exact domain modeling. I highly recommend this book. If anyone read the one from Eric Evans, Domain-Driven Design, you don't need that book if you read this one. But this has examples in F# and they're much more expressive. The same guy, Scott Vloschen, also wrote an article about F# as the best enterprise language nowadays. I highly recommend you to read it and take some inspiration. So let's get back to F# benefits. It's also cross-platform thanks to .NET Core. It has. You can use it not only for backend or desktop development. You can also use it for front-end thanks to Fable compiler. We'll talk about it in a moment. And one more cool feature is type providers. That's what I want to show separately, and I will need your attention to the code. So I have a simple, very simple application. It's a console application written in F#. This is my project file. You can see that I have only one package reference, which is F# data. And in our program file, program fs file, I have a constant issues URL, which points to the GitHub API of the Saturn framework, to the issues on the Saturn framework. With JSON provider, I create a type which is called GitHub issues, and I pass this URL and some name for the root object. That's not important now. And now I can have the issues, I can load them with that URL, and you can see that I have issues, and if I pass them, it's an array of so-called issue type. You can see issue array, and for example, if you want to iterate through that array, we can say that that's function I. And here you can see the properties of those issues. So this is ID, the created date, you can have labels, everything. So basically what type provider did, it has created a strongly typed object for me with for those issues from GitHub. So you don't need to describe those JSONs, those mappings, those serializations, deserializations. You don't care. It just does everything for you, and it's strongly statically typed, and you will see the errors on the compilation time if you need them. So we can, let's say, let's print, just print fn. Let's say it will be an ID and the title.
ID and title. So yeah, that's it. If we run this application, run. You can see the list. Oh, yeah. You can see the list of the issues on the Saturn framework. ID was not the best idea to use. Probably we should use number. That will show us more, better data. So yeah, these are the IDs and these are the titles from the issues directly from GitHub. There is nothing else in the project, you can see. So it's taken directly from GitHub. You can also use it to create issues, so that means sending post requests to the APIs. Type provider, it's not only about JSONs, it's also about SQL and HTML, and you can write your own basically. That's a really cool feature of F#. And yeah, that F# has also a really nice and supportive community. Just quick go through the syntax for those who are not familiar. So that's how we declare a function. The function has a name add, and it has two arguments, x and y, and we just sum them, add them together. But this function is statically typed, so it knows that these are integers, and we can add them together. With this syntax, when we have just space in between these arguments, this function is automatically carried. So carrying means that you don't have to pass all arguments at once. You can pass just one, like here, so just 10, and it will return a new function which expects just one argument after that. And this function will be called here add 10, and we can pass just 2, and this will be 12. Also, you can pass functions as arguments, as that's functional programming, of course you can do, because function is a first-class citizen. So you can, here I have a function as an argument, and I call it with two other arguments, x and z. Here, x and y, I show it here within brackets and with a comma. That's how you can make kind of all the arguments mandatory, because this is a tuple and it must have two parts, x and y. And then we can pass, this function automatically becomes generic, so you can pass other integers, or you can pass strings, and here you pass a function, what you do with those arguments. And especially here you can see that we pass just a minus, because minus is a function. Everything is a function, and everything is an expression. I told you about the type system, about especially algebraic data type system. That means that we have so-called sum types, and in F# they're called discriminated union types. It's similar to enums in C#, but it can have some extra data. For example, here we pass a temperature, or here it's a direction with some wind speed. And look here, it has not just float, but meters in seconds. So it's a unit of measure. F# supports units of measures, and you cannot, and then you cannot pass into wind speed. You cannot pass just float, or you cannot pass just I don't know, some other integer or another measure unit of measure type, like here degrees of Celsius. We can create windy with this weather. It's not a variable, it's a value called weather. We create it with windy, like here, but it becomes type weather. So then we can work with the type weather. This is called active patterns, and you can see that here we check the speed, and depending on the value, we return either high, medium, or low, and then we can pattern match against it. So we match our weather. So if it's cold and temperature here is less than 2 degrees, that's really cold. If it's cold, no matter which temperature it is, or it's wet, that's a miserable weather. If it's sunny, it's just nice. And here with windy, we pattern match it with high. But if you remember, it was a wind speed, which is flow, high. So with this active pattern, we see just high here, and we can check against it, which gives us really nice syntax for domain-driven design, where we describe the domain model, the domain language, the domain-specific language, just in pure English, not like something is more than something. You just write it once somewhere, and then you operate it in your business logic with real names. F# also has this mechanism of pipelines, which means that you can compose the functions. And here I show that when you have data, you pass it to one function, and the result of the execution will pass to this next one, and the next one, and the next one, and the next one. And you don't need to put everything into brackets, or you don't need to assign new variables or values in this case. You just pass them directly how they are. So let's talk about SafeStack. SafeStack is a set of technologies. It's not a framework. It's just kind of a recommended set of technologies for web development, cloud-ready web development, with a focus on type safety, thanks to F# as a type-safe and statically typed language. S stands for Saturn. It's a web framework on the server side. Azure is Azure. Everyone knows Azure. Fable is a F# to JavaScript compiler, and Elmish is the implementation of Elm architecture, so-called model view update architecture in F#. So let's have a look at Saturn. Saturn, it's a framework like everything in Safe. It's not something new. It's something already existing, just a bit better configured or abstracted for F# usage. So as for Saturn, it's just an abstraction over Giraffe, and Giraffe is another web framework, which is an abstraction over ASP.NET Core. So under the hood, there is anyway a Kestrel server, and Giraffe is implemented as a middleware, let's say. So Giraffe makes ASP.NET Core functional, and Saturn makes it even more declarative. It has so-called moons, which are Docker and simple migrations, which helps to work with the database, but you don't have to use them. They come together with the Safe template, but you don't have to use them. There are alternatives. As I told you, that Safe is not something strict. You don't have to use, first of all, you don't have to use the whole stack. You can use just some of the technologies. Or you can use just one, or you can replace some with something else. For example, with Saturn, you can replace it with Giraffe, the ASP.NET Core directly, and something completely different, S3A for free, or whatever you want. Saturn has its own template for .NET New, and its own CLI tool, which helps to generate some code. For example, with this line, you can generate books. It will generate controllers for you, views, entities, repository, everything. So then you will need, and with these properties actually. The next letter is A, which stands for Microsoft Azure. I don't think I need to present Microsoft Azure. Everyone knows that one. This is the recommended platform for cloud platform for Safe. Just probably because of the native .NET environment, and probably because from the very beginning it provided the services, not just virtual machines as AWS, Amazon AWS did. Also, you can replace it with AWS, Google, or just use it on premises, whatever you want. Safe runs in Docker thanks to Microsoft's images for containers. It has also them based on Alpine Linux, which makes them smaller and faster. Safe wouldn't exist and wouldn't be that important if there was not Fable. Fable is an F# to JavaScript compiler, which is similar to maybe to TypeScript, let's say. So there is TypeScript, which compiles to JavaScript. Here F# is compiled to JavaScript, and JavaScript is meant like another runtime for F#, like CLR in .NET, and here JavaScript will be the runtime. It has very simple interoperation with JavaScript, so if you really want, you don't need to use static typing. You can just fall back to objects and use kind of dynamic typing like we have in JavaScript, if it's really needed. The main Vue library used in Fable is React.js. React Native is also supported, so you can basically use Safe not only for web but also for mobile development. And it supports server-side rendering even without Node.js, which was needed for React.js if you use it directly. Alternatives are the Web Sharper. Similar thing basically, but yeah, it's up to you, you can use it. Or Bolero. Bolero is WebAssembly implementation in F#, based on a bit on Blazor, but that's not in the appropriate state yet. So just to wrap up, there is an F# code. It's being compiled with Fable to Babel.xt, and then Babel compiles it to ECMAScript 5, which is recognized by all the possible web browsers. Elmish. This is also a very important thing in functional programming, because there is such language as Elm, and it's not only a language, it's also an architecture where you have model, view, and update. Might be similar to Redux, but not exactly. Another benefit of it is that it has hot model replacement, so you don't need to re-click all the sequence of your actions when you develop something. So if your application is just in one state, you make some changes in the code, it's updated, and the state is being preserved. Just an overview on model view update architecture. In functional programming, we try to use pure functions as much as possible, which don't have any side effects. So you can really easily test them. You expect the same output for the same input. And here we have update function, which is pure, and we have view function, which is also very pure. It's just declarative representation of your HTML elements. It just outputs the HTML to the user depending on the model which comes to that view. Basically, that's it. If you receive one model, it will always output the same view. There is no logic inside. There could be some logic, but there's definitely no side effect. You cannot query an API in that view. You can also only issue a command, which means calling a dispatch function, that will come to the mailbox processor. And mailbox processor is our runtime, which is impure, of course. Yeah, that can make side effects. And then pass the result as a message to the update function, which will, depending on that message and depending on the current model, it will issue a new model. There is no mutating of state. It's just always a new model, a new state of model. Everything is immutable and pure. And then the cycle continues. And always, you just have everything declarative. View is declarative, there is no side effect. Model is just a model type, some state of your objects. And update just, again, gives new model depending on the message and the current state of the model. We'll see that in action a bit later. To communicate all those together, to combine those things like the front end and the back end, you need some kind of communication in between. You can always use it as just an API, and that will be REST, so HTTP requests with those GETs and POSTs. But we can do better. Since we have F# on both sides, on front end and back end, you can share some code, the models, even not only models, with Fable remoting, you can query your data from the API just by calling some functions. For you, it's just a function. It's not some HTTP request, nothing like that. You use it in an RPC style, just calling a function, getting the data, or passing some data to another function. Fable remoting has adapters for all possible safe servers, which are Suave, Saturn, and Giraffe, and ASP.NET Core. And it has, on the client side, it has also for Fable and for .NET native applications. You can use it from C#. There is also such thing as Elmish Bridge, which utilizes WebSockets and allows you bidirectional communication. So you can push some data from the server to the client. So this is an alternative to Signal-R, for example, but native to F# and to safe stack. With, of course, all those adapters for server and client sides as well. There is also such thing as Fake. It's not a part of Safe, but I would like to mention it because Fake, it's like make, but in F#, which utilizes the F# as a script language and gives us the possibility to write completely everything in F#. You can write backend code, server-side code. You can write front-end code in F#, and you can even write scripts in F#, which makes it F# everywhere and allows you to be not vendor locked if you need some building, testing, and deploying the application. Safe has some prerequisites, of course. That's .NET Core 2+. It's Node.js for building Fable applications because you need Fable and Fastpack. Yarn and VM, which VM comes with Node. Yarn is a separate thing, but the recommended one. Fake 5 is a .NET global tool. That's super simple. If you are a Mac OS or Linux user, you might still need Mono, but actually not necessarily. And in the new version, of F# and .NET Core, maybe you will not need Mono at all. Safe has a template, pretty flexible, so you can choose from different types of communication. The only one is supported is remoting, as far as I remember. Maybe now more. It's being developed every day, so you can see new features in the template quite often. You can choose how your application will look like. The recommended, not mainly the recommended, the most popular library is Fulma, which is an abstraction on Bulma, if you know that one. It's an alternative to Bootstrap, but without JavaScript at all. It's just CSS. You can choose from the deployment type, which is Docker, Azure, or Google Cloud. And you can choose from NPM or Yarn if you need to. The default is Yarn, but you can change it to NPM if needed. So let's look at some really simple demo, which will show you how it actually works. So I don't have an application. Let's create it from scratch. So that will be new, save, and I don't think we need to specify language anymore. This creates a very simple template for us, which has client, server, and shared parts. And let's have a look. Oh, well, let's run it actually. Yeah. Fake, build, target run. It will take just a moment to restore all the dependencies, and depending on the internet speed, it will be faster or not, but it looks good. Yeah. now we're waiting for the first load. You can see it here. The Fable compiler is compiling everything. So now, yeah, you can see that's a really simple application, which is a counter, and you can increase it and decrease it. Yeah. So let's keep it on 50. If you remember, the initial one was 42, and let's change something in the code, as I mentioned. So there is client, and on the client side, we have this syntax for the view. That's a domain-specific language, similar to Elm and similar to Giraffe view engine, but that's comes from Fable, from React actually. Here we use React as a view model, no, as a view library. So let's, for example, say that here somewhere here, this is press buttons. Okay, save template. This is navbar. So let's put something somewhere in the content. Yeah, somewhere here. So that will be heading. This is Fulma, so it has a lot of predefined elements. You don't have to use them. You can use directly divs or spans, whatever you want. But here I would like to still use Fulma and say hello GeekHub. GeekHub, right? Yeah. So basically, this is the HTML element, React element, which expects some arguments, the props, and the children. In this case, it's just a string hello GeekHub. And you can see hello GeekHub, and if you remember, 50 is being preserved because this is the state, this is the hot model replacement. I didn't do any compilation, I just saved the file, it was watched, and now we can see the changes, and also we can see the same state. There is such thing as React Redux tools, which is not installed because that's the guest. Okay, let's do it differently. No, and different. It's a guest. I don't need a guest. Let's run mine. Okay, let's use a new window. Localhost 8080. See the same thing. Should be. Yep. And we can see Redux tools. And here, let's dock it to the right. When I click here, I issue a command, and each command is recorded here. And you can jump to it and change the state of your application. So that's really helpful for debugging. Basically, that's kind of event sourcing. All those commands are just events, and they're executed one by one. Let me show you the function where it actually happens. This is our function update. As I told you, there is a message and the current model, and depending on the current model, in this case it's just a counter. We have only one property there, counter, and the message. We decide what to do, which new model to return. So if we have some counter, so it's sum, and the command is increment, we basically return the next model, which is the current model with new counter +1, or -1 for decrement. And then we return the model and no command. So we can also return some command, which is being done on the init state because we want to load that initial counter from the server. You can see here that we call the initial counter. Oh, I forgot to use the Fable remote. Here, yeah, here it's just a fetch. I hope someone is familiar with fetch. On the client side, there is such API as fetch for querying, for making HTTP requests. And here it's done with just returns the API from the API, and on the API side we have it. That's the Saturn application, which is very simple and declarative. We can have an application with some URL, we use some router, and some configurations for caching and serialization, probably, if you want to change it somehow. And this is our router. For GET request to this endpoint, we return the counter. That's just initial counter. And that's it. So if you want to add something else, we just add it here. Let's say get API hello, and that should return. You see this next and context things, because that's the way the middleware approach. So there is a pipeline with several middlewares. In this case, every handler is a middleware, so you can compare it to the middleware, and you can either call the next one or not. You don't have to. Like in this case, we can just actually return, so for example, controller text, hello, and yeah, of course we need. No, not this one. What was that? Okay, we need the context. Yeah, okay, context. Yeah, and it will return for us. Hello. And here it will call this 85 API hello. Yeah, it returns hello. So I hope you see it. Yeah. So that's I think pretty much it from my side about demo. We can go into details if you want, but let's for now go back to the presentation. Yeah. Just wrapping up. With safe stack F# language, we have really high performance, but that's not only thanks to F#, but mainly to .NET Core. We have really full stack development, including mobile development and even scripting in just one language. You don't need anything else. You can even write CSS in F# with just another library. That's super simple. And maybe the most important here is type safety. That's why we like this acronym SAFE, because really it's type safe. All those compilation errors help a lot, especially in refactoring and making sure you don't pass some bullshit into your function, like that could happen in JavaScript. To know more, you can use SafeStack website that has documentation, examples, and more resources. Saturn framework has its own site with the documentation, of course, Fable as well. And I highly recommend F# for Fun and Profit from Scott Floschen. It has a lot of resources about F# modeling and F# for C# developers. So a lot of information really to understand it better and see the beauty and the power of that language. That's it. Which questions do you have?
Yeah. Can you show us real power of F#? Maybe define any project that can do it, or you have any project like real power. Why do I need to use F#? Which project can I create here?
Do you want to see the code, or do you want to see the real project?
Like how does it look like real project with F#?
That's jet.com. Do you know that one?
Yeah.
Yeah. So this is fully written in F#. Jet utilizes F# everywhere.
Wow.
Yeah.
So yeah, that's nice.
Jet. Come on, that's not one. No? This one? No. Yeah, I think this one. Yes. Jet. Tom. F#. You can find more information about it. They share a lot, but maybe not everything, of course, because that's an enterprise company. They utilize it everywhere. I mean, that's maybe Jet.com is the biggest user of F# overall in the world. Maybe, I'm not sure. Microsoft is not that happy. I mean, they don't push it that much as C#. It's still more language for some research, probably. That's how many people consider F#. But actually, F# solves the same problems as C# easily and much more. Especially with Fable, you don't really need any other language. You just need one everywhere. You cannot do that with C#. And with its specific data system, you can describe the domain model much more expressively. F# is it's sometimes, like maybe not sometimes, it's treated as a language which is clear and understandable by non-technical people. You can describe it with just those discriminated unions, and you won't see even a keyword like int or float, which is what is int or what is float for a non-technical person. That person doesn't know it. But with F#, you won't see that word at all. You won't see probably any keyword at all for the domain model, let's say. Not maybe for the whole logic, but for describing the real domain. You can avoid keywords, almost avoid them completely. Like you will need something like type, of course, but everything else will be just pure English. And even the signatures of the functions will be written as a workflow, which is understandable by non-technical people. Like there is, I don't know, let's imagine an order. And in the real world, an order which comes from the customer and the order which is validated, then processed and then shipped, these are basically different things, completely different entities. But very often in the development I saw that it's just one object with a lot of properties and they are either null or not at some point. But with F#, with the different approach, with the immutability approach, I would just use different types, absolutely different types for these states of order, and that will be very helpful on the compilation time. I won't need to write unit tests to check if that order is in the correct state. I will just use just another type, and it won't compile even. So yeah, it simplifies a lot. Yeah, you need to kind of get used to it because for us, I'm also a C# developer more than 10 years, and I had to switch my mind completely because it's a different paradigm. It's functional programming, it's immutability by default. There is no, well, there are classes actually. You can write F# in object-oriented approach, but you kind of wouldn't do that. That's not idiomatic. So I would recommend to use F# as it is, like yeah, with the functional approach.
Sorry, I didn't completely get the first example. Did you have to download the JSON first because you saw the IntelliSense app? But yes. I didn't get if you, like for example, in C# you can paste it as a class and it will create a class for you, but I haven't seen anything like this in your example.
Yeah,
just something, and then there was the IntelliSense.
Yeah, that's the power of type provider.
But you have to run some command to download the JSON
No,
files.
you don't need to do that manually. That's done. Behind the scenes, and you can also provide not a URL. You can provide a file, for example, a file or just a string with a JSON, and it will recognize it. And maybe if you want to change it, for example, that's useful when you have CI server, where you don't want to download something from any other URL. You just use a file, a static plain text file where you have that description of a JSON. And it's very smart actually, because for example in F# we don't have such thing, well, we have such thing as null, but it's recommended not to use nulls, and instead of nulls we use so-called option type, right? So that's some or none, and the type provider is smart enough to understand that some value could be either present or not, and that let's use option type for it, option of integer, let's say, or something else. Yeah. So everything is immutable. Like I didn't show you the record types, which is also a very powerful thing. Record type looks like similar to a JSON, but it's being compared by the values, not by reference. But it's a reference type, but it's compared by reference because it has all those equality members overridden to check to compare them by the values, and they cannot be null. You must initialize them with some value. If you want explicitly to have some missing value, use option type. That's also very important in the domain-driven development. You want to explicitly see where some values are missing. They might be missing. Otherwise, you expect a string and you receive null, but you are not prepared for that. So in F# we really don't have that null pointer exceptions almost at all. We don't sketch it like. Yeah.
You showed the immutability example, but it was like under the hood only by the state management of the Redux. What are the different use cases and examples of immutability, for example, in the backend?
Everything is immutable by default. You cannot change it.
You cannot change it in play. There are no objects, and you cannot change any properties.
Yeah, you cannot change a property. Let me show you. Let's have a type, some full type as usual, with some prop1. It's a string. Oh. Yeah, and let's create such type, which will be prop1 equals my prop. And here, foo prop1, if I say it equals to something else, the result of this expression will be a boolean, because equals sign is used for comparison. It's not assignment. If you want to try assignment, you can try assignment, but that won't work. That won't allow, because that's not mutable. You can use mutability, like you don't have. I mean, it's possible. You can say that this prop is mutable, and then you will be able to mutate it. But that's it's recommended to avoid such situation. You don't really need that. Pure function, in functional programming, we try to use mainly pure functions, which means there are no side effects or state changes. It's a function which gets one argument, for example, one argument, whatever, any amount of arguments, and returns the same result if you give it the same input. Like if you send 5, you receive 25 always. If you send 6, it will be, for example, 36. Let's say, right? So it's easy to test, and there is no state mutation. So basically, it receives one model and outputs another model, another instance always. It's not changing something. It's new thing. It's immutable new instance, even if of the same type.
If
you define a function, can you explicitly say that it should take only 2 integers? Like
Yes, yes, yeah. That's maybe not. I didn't show it. That's not correct. But when you define a function, you can say that x will be integer, and I don't know, y should also be integer. Mainly just, and here you see the signature of this function. Actually, this is called type inference, and for C# developers, it is familiar thing. For example, in LinQ, when you have, let's say, select extension method, and you pass a lambda, and you don't say that this x. Look, you can, and sometimes you must, but usually you don't provide a type, right? So it's inferred from the context. And in F#, it's almost always is done from the context. It finds which type it should be, and that makes the language less verbose. You have much less keywords. You write just really what matters. The name of a function, that's what matters. I don't know, it's public, static, read-only, void, blah, blah, blah. A lot of noise, which you don't have here. It's just a function add, and that's everything what I want to know about it. You can always hover it if you don't have that helper with the signature. You can always know the types easily. Yeah. So it's statically typed. It's not like in JavaScript where you can just pass whatever you want into the argument. It will be treated differently. But here it will be checked on the compilation time.
If you have a solution, let's say, and there is some project in C#, can you add for the same solution a project in F#?
Yes.
Call them each?
Yes, that's definitely possible. But I must warn you about the tooling. Tooling is sometimes not working properly. Even Visual Studio, the big version, the full version, Visual Studio Code with Ionide plugin, they are both, they not always work correctly with such solutions. So you might experience some IntelliSense issues, some IntelliSense errors, but it will compile, for example. So that's harder on the tooling moment when you really write the code and you want IntelliSense, for example, that won't work. But if you compile, that works. I mean, if you wrote everything correctly.
It compiles to the same.
Anyway, that's that intermediate language in .NET. That's the same thing, just a bit different tree.
So it means that from C# code I can call F# methods?
Yes, and vice versa easily. Yeah, easily. Basically, it's in this case, for example, it will be compiled into static class with a static method.
Okay.
Yeah.
Question regarding your example, when you use the review logic, is it possible to use JS6 syntax for that, for example?
It is JS6. I mean, that's not JS6. It's F# alternative. Basically, the same thing.
I mean, to make it look the same way, so when you write just JS6, you just almost see the exact markup.
No, that's the biggest difference, but it's very easy to get used to it, actually. That's F# language of all the way to the bottom, I mean, to everywhere. And that's, you know, you can write React code without JS6, right? So you can write just pure JavaScript, React, create element, pass the name of that element and the props and the children, right? So basically here we have the same thing. So it's a function which takes two arguments. One is props and the second one is children. So, and we use it as function, and of course you can work with them as functions, and that's the key benefit of F#. You still work with, even with those elements as with functions and with carrying. So you can pass just one argument firstly, and later on reuse that part, passing just the last argument to it. Like a partial application is an alternative to dependency injection. So you inject something into your function initially, and then reuse that kind of container for that, and reuse some parts just on the functions level, not on classes or objects.
And just I didn't quite catch that moment. Does your example application use Redux under the hood?
No, there is no Redux.
But Redux
Tools work.
Cached it. So
Yeah.
we use similar state management. No, I don't know just how Redux tools work. So
Basically, yeah, Redux tools works thanks to the implementation of Elmish, because that one triggers the things which Redux tools catch. So it's like kind of, if you don't set debugging mode, it won't work.
yeah.
So Elm architecture, the implementation of Elm architecture in F# is actually, if in a Redux there is really one mutable variable, which on every dispatch it's being replaced by something new. It's a mutable variable actually. And if you check the code of Redux, there is a mutable variable under the hood actually. It's not immutable at all. There is something mutable. But with Elmish architecture, there isn't anything mutable at all, really, because there is kind of a loop, infinite loop, which executes, returns new value all the time. There is nothing replaced, nothing mutated. It's just new. If something comes inside, it returns a new model. Otherwise, it just waits for the new message.
Okay, next to a speech. There's this also. Yeah, that's my question.
One more question. How much is this Sharp adopted by real commercial companies? Like, I mean, are there any companies, for example, in Prague which use F#
Yes.
as the main language for their projects, yes. Or how is it difficult for you to find some job position as 100% F# developer? How much is difficult for companies to find F# developers?
Well, that's, I must admit that it's definitely easier to find C# job than F#, of course. And this is a problem of a chicken and the egg, because companies complain that it's hard to find F# developers, and F# developers complain that it's hard to find a job in F#. In Prague, there are several companies which use F# as maybe not the main language, but on some projects it's the only language. I wouldn't make any advertisements, but yeah, there are companies, and in those companies there is an internal queue of developers who want to switch from C# to F#. So they basically don't hire that much from the side. Yeah, and I know, for example, a company which has some projects in F#, and those teams are so efficient and have such huge velocity and speed. Then other teams in other languages, they just cannot catch up with them, and that's why they hire for different languages but not for F#. There's no need for new developers in F# in that particular company. That's how it is. I mean, that's. I'm not saying that it's the silver bullet. I found F# as much more suitable for real-world development than C#, where I don't. Well, there are many problems which are already solved in the language itself without all those workarounds. I don't need to. I don't know. I don't need to check if the collection is null before iterating over it. I know that it will be either not null, or I will receive a different type that will be optional with that collection. Then I can work with it differently. Yeah.
Okay, one more question. Are there any limits if you, for example, reference some .NET C# compiled library from F#? If this C# library calls some Windows API or some C library or OpenGL code, I mean, if F# can call some like .NET library which can call some Windows API in C?
It's up to the runtime. If it's .NET Core which doesn't support Vim forms yet, that won't work even in C#. That means it won't work in F#.
Okay, so anything you compile
Yeah,
in
exactly.
C#?
Yeah, exactly. Except Fable. For Fable, the libraries should be prepared for Fable. So not everything could be compiled into JavaScript, but almost every API from .NET, even, I don't know, for example, a very simple example, like datetime. Datetime in .NET is one thing, and in JavaScript it's a different thing. But Fable is smart enough to compile datetime from .NET to JavaScript datetime, date representation, date object. So, and for other APIs as well, but to some extent, I mean, that's, if you want to use Fable, a library in Fable, you must use Fable-ready library, let's say. But there are a lot of them already, and it's not a problem. I mean, it's not.
So you can, for example, use even unsigned integers.
Yeah, definitely.
So, okay, thank you so much again.